MusicSchoolPrep.com. Lesson 7. Inversions of Intervals. By inversion of an interval, what we are really talking about is an octave change of one note in an interval. This is very easy to understand with examples. Here we have an interval of a perfect fifth between a C and a G. Now we are going to move this C up one octave and leave the G where it is at. This is an inversion. When doing this, notice that the pitch names are the same, but the interval has changed. Here we actually have a perfect fourth. Here's another example. As long as one of the notes changes octaves, we have an inversion. It does not matter whether it's the first or second note. We start with a minor third from this A to C, but when we bring down to C, we actually have a major sixth. Calculating the new interval is quite simple. The quantity of an inverted interval can be calculated by subtracting the original interval's quantity from 9. This exercise gets us with the quantity only, and we will not be concerned with quality yet. Here's a list of examples. In this first example, if we had a minor second, we would subtract that from 9 to get 7, which means the new quantity is a seventh. Next, if we had a major third, we would subtract the quantity 3 from 9 to get 6. This means the inverted interval's quantity would be a sixth. And this pattern, as you can see, continues all the way down the list of inverted intervals. Now that we know how to find the quantity of an inverted interval, we will learn how to calculate the quality of an inverted interval. This is also a very simple task. First, perfect intervals, when inverted, produce perfect intervals. This is actually why they are called perfect, because even when inverted, they remain perfect intervals. Major intervals, when inverted, produce minor intervals, and vice versa. And augmented intervals, when inverted, produce diminished intervals, and vice versa. Here are some examples. Here we have a perfect fifth, so 9 minus 5 gives us 4. We know the quantity is a fourth. Then, as we just discussed, perfect intervals, when inverted, produce perfect intervals. So this inversion results in a perfect fourth. Here we have a minor third, so 9 minus 3 gives us 6. We know the quantity is a sixth. Then, as we just discussed, minor intervals, when inverted, produce major intervals and vice versa. So this inversion results in a major sixth. Here we have a diminished fifth interval, so 9 minus 5 gives us 4. We know the quantity is a fourth. And as we just discussed, diminished intervals, when inverted, produce augmented intervals and vice versa. So this inversion results in an augmented fourth.